All right, so let's move with another question. Question 18. Transverse wave moves along a rope. The diagram shows the position of the rope at one particular time. So let's remember, transfer wave is this type of wave, yeah? It moves up and down. For example, light is transfer. Another type was what? Transfer and longitudinal. For example, sound is longitudinal, back and forth, yeah? But going up and down, which is in this case, it's going to be, yeah, a transverse wave. For example, water or the light maybe, yeah? The diagram shows the position of the rope at one particular time. So which two labeled points are one wavelength? So what is wavelength? From one point to another same consecutive point, yeah? So it is, well, we have certain options here. So let's go with options better in this case. WZ, from W to Z, it's this one, it's maybe 1/4 only, it's not an option. WX, yeah. W to Z, it's, well, from here till here, yeah, it's too long, it's more than one wave. X to Z, from X to Z, this is actually from single points, like coming here and, yeah, goes and coming to that point. Yeah, exactly, this is one wave actually, yeah. YZ, it's like we had WX, it's not 1/4 but 2/4, so half of the wave, so it's wrong, yeah. So yes, it's easy. See, question 19. Light in transparent plastic meets a boundary with air. Light is transmitted into air only if the angle marked in the picture, in the diagram, is greater than 36. Let's say it's going to be greater than 36, then it's going to go from plastic to air. Then it's going to happen refraction. Well, you may have little confusions in your mind. Critical angle, it's supposed to be less than that or more than that. Here it says more, but it's supposed to be, if it's more, it used to be total internal reflection. Why it's saying greater than? If it's greater, it's supposed to be not refraction but reflection, yeah? So let's read the question. I will explain this one. What is the refractive index of the plastic? Well, refractive index actually happens, or you can find with critical point as well. So which using n equals to 1 sine c, or you have learned maybe from your teachers to be sine c equals to 1 over n. Both are correct, just what? Changing sine c and places, yeah. N is going to be refractive index, c is going to be critical angle, okay? This is critical angle. The angle, that specific one point of angle, let's say, to distinguish between refraction and the reflection is basically, yeah. Now, let's check out, what is C? C is the critical angle. Where is the critical angle? Critical angle is going to be between the normal line and the light. If it's more than, it will be totally internally reflected. If it's less, then it will be refracted. Now, the minimum of this means maximum of this. That's why they are saying greater than 36, okay? They are not talking about critical angle. They are talking other side of the critical angle. So C is going to be, the 36 is the minimum point actually, yeah? Just before reflection happens, let's say, yeah? Minimum of C basically, yeah. So what is C here? If it's 36 plus C should be 90, then C would be 54, isn't it? All right, so it's in degrees. Be very careful. If you check your calculators, if it's radian, change to degree, yeah. So n equals to 1 over sine 54, then n would be very close to 1.2, okay? Unit, it doesn't have unit, it's just a index, yeah, it's a comparison index, yes, exactly. So 1.2. Question 20. A thin converging lens has a focal length f. Oh, so we have two focal lengths. This is our focal point then. All right. An object O is placed. This is our object O here, okay? So, let me erase this one. Okay. On the left of the lens as shown here, what's the image formed and how does the size compare to the object here? In order to find the image, we have to draw what? Ray diagram, yes, exactly. So let's see if we have, oops, sorry, my bad. Let's see if we have a such thing. Ruler, tag, page, shape, yes. Oh, pro version. Okay. We don't have line here. Interesting. Text, sticker, image, page. No problem. I will use ruler for mine. Okay, I try to, yeah, really show the ruler from the program. It didn't. So okay. Now, first of all, sorry, my bad. Okay, what we will do? So we will ray diagram, guys. Don't forget, it will be always with two lines. So one line is the parallel straight. Okay. Okay. Give me a second. It goes something like this here, and it goes from the focal point. Yeah. So it goes this way. Okay. It goes this way. The second one, this is one line. Second one goes from the center of the lens, from the same point. Okay. It goes this way. So we always draw two lines, okay guys? So line 1 and line 2. So see, line 2 is going here, line 1 is going there. They never meet. Even you may remember from your teacher maybe gave you the notes, yeah? If the object placed between the lens and the focal point, you will not meet the lights. You have to extend them back, okay? Which is going to be what? Virtual, exactly. So it's going to be virtual here. They meet the extension part. So this is our image actually, guys, okay? So what is this image? Where is it? The image position, what's the size? Let's see. On the same direction, not opposite, on the same and same. It's larger than the object, exactly, not smaller. So it's going to be C, everyone, okay? It's larger. Oh, they're singing very nice, yeah. All right. Question 21. Which diagram shows what happens when ray of light passes through a prism here? Now, A is definitely wrong, guys. This is white light, yes, they are all combined, but once it passes from air to glass, simply prism, it starts dispersing basically, yeah? So what we have B, C, and D. So we have eliminated A here. Now, which one is correct? B, C, and D. So second point, let's check B. What happens as it passes through the prism? Well, you may remember the picture if you're very good in remembering, but personally I'm not. So what we will do here, the rule. We can go over the general rule. Sometimes if they change the orientation of the prism, it might be a little difficult for you to find the answer. So better to know the rules here. So this is the surface, and we will have a normal line, always perpendicular to the surface. Now, initially, incident, yeah, we call it incident, let's say. White light was, let's take it a little white light, yeah. So it's supposed to go this way, but due to the glass, it's going to bend. Is it towards the normal line or away from the normal line? So it goes from air to glass, from loose to dense zone. It will slow down and it will bend towards the normal line, okay? Don't forget. So from loose to dense zones, okay, it will be towards the normal line, okay? Normal line, which one is normal line? This is the normal line, okay? We just drew it, normal line. All right, so it will be, of course, banded towards the normal line, all right? So which makes the B wrong. So C and D is correct, okay. So it means after prism, it will be correct. Which one is correct? So A and B is gone. Let's check the C, if it's correct or wrong. All right, again, we'll go. Okay, again, same thing, okay? So pick one, doesn't matter, you can pick any. Let's pick the last one, easy, okay? It was going this way. Now, this is going to be our surface, all right? We'll again draw the normal line, okay? We'll draw the normal line now. All right, let's pick this one again, okay? It's supposed to go this way, if no boundary here. Now, due to the boundary, it will bend. Where it will bend? It goes opposite now, from glass to air. It will speed up. If it speeds up, guys, it's not going to bend towards. If it's from dense, oh, to lose, okay, it will go away from the normal line, okay? You may remember this way. So it's supposed to go where? It's supposed to go away, not here, but the away. Here. So it makes C wrong, definitely. Wow. So they put to the final one to work on every that one. Oh, they're sneaky. No problem. So it's D. All right. So check out. It's bent towards. Even here, see, it's went even what? More than the normal line. By the way, another point, guys. Lights is not going to bend passing from the normal line. Okay, it never does. All right. 22. A television TV station transmits a signal to a television receiving dish antenna, simply. A television has an on and off indicator light, okay? A television is switched on by a remote control which changes the indicator light from red to green, okay? Which electromagnetic wave used in these actions have the longest wavelength? Oh, longest wavelength. Simply, let's say A, B, C, and D. So, from TV to satellite, we have radio waves. From satellite to antenna, we will have microwaves, guys. From remote to TV, we will have infrared, yeah? And the green and the red lights are visible lights, definitely, visible lights. All right, which one has the longest wavelength? Guys, radio is the definitely longest, so our answer is A. So let's remember, so longest wavelength to shortest wavelength waves. So in general, we had 7, yeah? From radio waves to microwaves to what? Infrared to visible lights to ultraviolet UV, X-ray and gamma rays, yeah. So simply 7. So radio has the longest, gamma has the least, shortest wavelength. When you talk about frequency, it's opposite. Gamma rays has the highest frequency, radio waves have the lowest frequency, but the wavelength is opposite, yeah? All right, so radio has the longest, so it's going to be A, guys. All right, so question 23. A student makes a list of the applications of waves, medical scanning of tissue, sterilizing water, using sonar to calculate the ocean depth. Which application uses ultrasound? Oh, ultrasound. Okay. Which ones? Yeah, correct. Medical scanning, tissue. How we find the stone in our let's say, kidneys. Basically, yes, this is ultrasound. Sterilizing, it's UV, X-rays or gamma rays, not ultrasound. Using sonar, it's sonar calculate ocean depth, exactly. So 1 and 3, guys. 1 and 3. It's C. Another question. Diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. While the wire is released, of course, this is gonna attach to the magnet, yeah? Let's see. What happens? Oh, yeah, the wire moves away from the magnet. Not definitely. This is magnet. This is magnetic material. Magnetic material, yeah? The wire moves towards the magnet. Exactly, it's B. The wire center stays blah, blah. No, it's not that, yeah? So, it's B. Which diagram shows the electric field pattern in the direction around positive point charge? Positive point charge. Well, these are what? Definitely wrong, yeah? It's not the point charge. They are currents in the wire. Yeah. So, positive, it will always send out, guys. Negative will receive. Always, don't forget, okay? Okay, cool. Question number 26. A lab or laboratory has a standard wire of known resistance. It also has other wire made from the same material, okay, we can compare now, as a standard wire but different length and diameter, so different length and area. Which wire would definitely have a resistance of less than the standard wire? The first one, yeah? First one has R, ours R1, R standard, let's say, and R second, so definitely R second is less than the R standard. Yeah, which one? So resistance is, guys, directly related. Oh, the sign would be what? The grammar, yeah, let's say. So sign would be directly related to length, and resistance inversely related to area. Simply, if you increase length, you will increase resistance. So in this case, less. If you decrease resistance, you have to decrease the length. So length should be shorter, guys, not B or A. How about area? Inversely related. So this was related to the directly related to resistance, and the area indirectly, so it's going to be larger area, yeah, we say. So it's going to be C, guys, not smaller. Yeah. Next question, 27. The graph shows the relationship between the current in a circuit component and the potential difference PD cross it. So simply resistance, yeah, resistance curve, R curve. The graph has a straight section and a curved section. So let's say this is going to be straight section, the section A, and the curved section, section B. So simply ohmic part and non-ohmic part. A to be ohmic, B going to be non-ohmic. Okay. What happens to the resistance of the component into these two sections? Yeah, as the current increases. As the current increases, so let's call straight sections so A and the curved section B. In ohmic part, it always resistance is same, yeah? So it's straight line. So if this is 2, do 2, it's going to be 1. Maybe this is 4, this will be 4, 2. So linearly increasing, so it will be again 1. So no change in resistance, guys, okay? So A and B is definitely wrong, C and D. What happens in the curve? So check this one out. So as in the curving part current increases, resistance will decrease or increase here. So we will go to the formula, Ohm's law actually, yeah? So resistance equals to V over I. So check, which one is going to increase more? They used to increase same before, yeah? In the straight line. That's why it's constant. But the change, if it's V change more, means resistance increases. If I change more, resistance will decrease. So let's check. So from here to here, let's say, we will have this much of increase. Let's check the PD, potential difference. We have this much of increase. So changing PD is higher than changing current. Okay, changing voltage, PD is voltage, potential difference, okay? It's a voltage. So definitely this will win, okay? So resistance will increase too when changing voltage increases. So resistance will increase, guys. 27 is going to be D. All right, 28. So wow, it's a connection, yeah? Series parallel connections both together. What is the combined resistance of the resistors here? So, well, yeah, we'll go with the easy one, series. Okay, we'll combine them first. So, how we gonna combine? They are in series, so simply equivalent to 1. Let's say R1 plus R2, which is going to be 2 plus 1, 3 omega. But when we combine them together, guys, it's going to be what? 1 over parallel connection, yeah? 1 over R equivalent, let's say, or total, yeah? 1 over R equivalent 1 plus 1 over 4. Simply 1 over, we found 3 plus 1 over 4. It's gonna make, so we give 4 here, we give 3 here. Simple mathematics. 4 plus 3. 4 plus 3 divided by 12. So 1 over R equivalent equals to 7 over 12. So now reverse them, yeah? Reverse them, or simply cross product and find R equivalent back. R equivalent is going to be 12 over 7, or simply 1.7 omega. Simply C. All right, another electricity problem. The diagram shows a circuit which includes 2 resistors and a battery. So this is battery, let's say, yeah? This is going to be a battery. So this is plus side, this is minus side, yeah? The voltmeter reads the first guy to be 6 volts. What is the potential difference across the 30 resistor, ohm resistor? So guys, feel free, even in the exam, write on the paper This is what? This is paper 2. Your question paper is not going to be sent for check, okay? So your answer sheet is going to be checked. So feel free to write on the questions directly. So simply just write it 1, just write it 2. First component, second component. So we are given voltage 1 here, okay? And they are what series connected components. So simply just go with the voltage. Total voltage is what? Total voltage is going to be volt 1 plus volt 2, isn't it? Now let's remember our Ohm's law. R equals to V over I, okay? Then our V is going to be R times I. This is our general formula. Can I simply say V total is going to be R total times I total equals to, well, V1 is directly given, yeah? So V1 is 6 volts. I can just write it 6 volt here. 6 volt plus V2 is going to be what? Remember, V2 is R2 I2. And this is series connection. Don't forget, it's going to be what? I total equals to I1 equals to I2, yeah? So simply let's call it as I. All right. R total, it's in series. So R total is going to be 10 plus 30, which is going to be 40 omega. So let's say 40 omega times I equals to 6 plus R2 is given as, this is R2, yeah? So R2 is going to be 30 omega. So 30 times I, all right, take this 30 to other side, it becomes 10I equals to 6, I equals to 6 over 10, 0.6 ampere. But this is not the question. So the question is, what is the voltage, potential difference, voltage consumed in the second component? So we will use this one definitely. So our what? Our V2 equals to R2 I2. So R2 given as 30 ohms, ampere 0.6, always same in this series. Voltage equals to 30 times 0.6, so 6 times 3 basically 18 volts here. All right, so it's gonna be 18 volts. It is C. Nice. All right, so another question, question 30. A wire is moved down in a direction perpendicular to the magnetic field. 3 changes are suggested. Speed of the motion, movement of the wire basically, is increased. The magnetic field strength is decreased. The direction of the magnetic field is reversed. Which changes increase the electromotive force? So induced current would be increased, yeah? Induced EMF induced in the wire. So which one would increase? So if you move faster, motion is increased, it would increase EMF. Strength decreased of the magnets, it would decrease. Direction reversed, it's not gonna change anything, okay? So only one here. So which change or change, yeah? That's the question, correct question, yeah. All right, 31. A wire is moved across a magnetic field. Oh, it's what? Just a link to the previous question, yeah? Not linked, I mean simply, yeah, same topic. A wire is moved across a magnetic field. This causes induced current in the wire. So the induced current interacts with the magnetic field to produce force on the wire. So in which direction the force will act? In the direction of the current? Definitely not. Opposite, like opposite or in the same direction of current, it's going to be total different direction. In the direction of the motion or in the opposite direction of the motion? Which one? It would be in the opposite direction, guys, always. So when the magnet is, so current is induced, so what will happen? So when the metal cuts the magnetic field, the electricity, basically current, is going to be induced in that metal, in that conductor. Okay, it should be conductor. So the force due to the interaction of the current created in the conductor, it will create its magnetic field around itself. And the magnet from the magnetic side, they will interact with each other. So there will be force definitely, and it will be always opposite to the direction of the movement you apply. So it's going to be opposite. So D. Question 32. 100% efficient step down transformer. So be very careful. Step down transformer has primary voltage and primary current, which raw compares the secondary voltage and the secondary current. All right, first of all, what is step down transformer? It will lower the voltage definitely. So we'll have a transformer here. Let's draw. What is the what is the definition of the step down, or how we will just by looking at the picture know it's step up or step down? So step down, it will have more turns in the primary, guys, okay? It will be less turns in the secondary. That's why the number of turns are directly related to the voltage basically. So N primary is always bigger than the N secondary. So voltage primary will be always greater than the secondary. The current is opposite, guys, always opposite, okay? So current primary, if voltage is higher, current will be less, okay? This is the main point of using transformer basically. So just a review. So why we'll use transformer? To reduce the current in order to avoid waste or losing energy while transferring electricity, yeah? Anyway, so this is secondary. So let's compare. Secondary voltage is lower, less. So eliminate A and B. Current is going to be greater. Definitely, it's going to be C, everyone. Okay? Correct answer is C. The scattering of alpha particles, Rutherford's experiment simply. Rutherford, yeah. So scattering of alpha particles by thin metal of foil supports the nuclear model of an atom. So why we use alpha particle rather than the neutrons? Why we use alpha? If it's, let's say, neutron, it would not deflect, yeah? So center of atom will have, well, neutron here, so neutron. So when the passing by a ray, it's plus will deflect. That's why we have it. If it's neutron, it would not, we would not know the charge of the nucleus basically, yeah? So because they have positive charge, this is what I'm trying to say, yeah. If it's neutron, it would not deflect, definitely. An iron nuclide is represented by the symbol shown to us, yeah, Fe. Which statement about this a nucleus of the iron nuclide are correct or is correct? Okay. Statement of statements again, yeah. So don't rely on statements means more than one, yeah. So it might be one only as well. So we have seen, yeah, before. The nucleus contains 56 neutrons. This is what, guys? This is nuclear number. It's proton plus neutron. And 26 is proton, yeah? So it's not neutron. Neutron plus, so this is wrong. The nucleon number is 30. This is called nucleon. Nucleon. NU, sorry. So nucleon, yeah? So it's going to be not it's 30, but it's 56. This is wrong too. Proton number is 26, as I said, yeah? Statement or statements. So 3 only is the correct answer. 34 is D, guys. 35. Okay. A sample of the radioactive isotope has an initial rate of emission 28 counts per minute. So this is our initial one. And the half-life of 4 days. How long it will take for the rate of emission to fall to 32? So from 128 count per second to 32 count per minute, yeah? So 128 counts per minute to 32 counts per minute. How many days? All right. So 128, after one half-life, it will reduce to half of it. So it will be one half-life reduced to 64. This is one half-life, which is 4 days, yeah? Are we there? No, we should not stop till 32. So then 32, oh, we stop here. 4 days more. All right, so we stop here. How many days? 4 plus 4 gonna make it 8 days, okay? This is simply half-life. Half-life is a time needed to reduce the amount into half. 2 half-life each 4, so it's 8 days. All right, 36. Several scientists are working in a lab. The scientists are experimenting with the sources which emit ionizing radiation, so radioactivity. Each scientist is given the list of the safety rules. 3 rules are shown. Which safety rules are for protection against the effect of ionization, guys? Okay. Keep at least 2 meters away from each other. Well, about the rules, it doesn't much make sense, this one. Let's go with 2. Do not stay longer than 4 hours per day in the lab. Well, it's not really specifying the time, but it's like minimize the time. Yeah, probably it's correct. Yeah. Stay behind the lead lined screen. Yes, this is correct. So it's going to be definitely, if you're not sure about 3 as well, sorry, 2 as well. So 3 is correct, definitely. Let's look for the options with 3. 1, oh, except B, they all have it. So 1 doesn't make sense. Yeah. 1 is not there, 1 is not there, so definitely D is correct. So 36 is going to be D, guys. Okay, so keeping 2 meters away from other people, it's not about the ionizing. Yeah, it's like alpha have just few centimeters, guys, here for instance. Yeah, the most ionizing one, so 2 meters doesn't make sense here. All right, which data is needed to calculate the average orbital speed of satellite around the planet? So which data gives what? Average orbital speed. Now, in order to answer this question, first of all, let's find the what's average, or let's say orbital speed. Simply, speed is going to be distance over time, guys. But in orbital case, this is the planet and the satellite is going with the, let's say this is the satellite. Yeah, let's say. Okay, let's say. All right. So simply, speed is going to be distance over time. Distance for this guy to make the orbit is going to be circumference of the circle here. So simply 2 pi r. And the time to make one complete cycle, let's say it's simply the period of the, let's say completion oscillation, also, let's say, yeah. So it's going to be t, simply 2 pi r over t. T is the time, yeah, to complete one cycle. So simply 2 pi r over t, or simply big T or small t. So you understood, yeah? So, by the way, what's r? Guys, in a r, it's going to be, let's say this is going to be the planet, let's say, yeah? This is going to be planet. Now, r is going to be distance from the center, guys. You may rely for your geometry, let's say, yeah? Skills. This is going to be r from the center of the planet to the, let's say, to the center of the satellite. So comparing 2 small, so you can just say satellite here. Yeah, let's go over the options we have. Distance of the satellite from the center of the planet. That's correct, everyone. So C definitely wrong here. The radius of the planet. Well, not radius. Yeah, it's included already there. So it's going to be this one. This is wrong. This wrong. This wrong. Well, it's already B. Yeah. The period of the rotation of the planet. The period of the planet, guys. We're not looking for the planet. We are looking for the satellite only. So not needed. Not needed. Yeah. Definitely makes A and C wrong. Definitely. Yeah. And time for the satellite to orbit the planet once. Definitely, this is the definition of the T. Yeah, it's B. Yeah, as I said. All right. 36. Approximately how long does it take for the moon to make one complete orbit of the Earth? Moon completing the Earth, 28 days, yeah, 27, 28 days, yeah. So around 1 month. Yeah, we have only option 1 month, yeah. Not 1 day, not 1 season, not 1 year. It's B. 39. We are almost there. So the energy generated in stable stars come from the nuclear reactions. What is the stable stars? So if you remember the what formula we have learned, the phenomena, nebula hypothesis, yeah? So there we say it's stable stars. What is stable stars? Sequence stars, yeah? So energy generated in sequence star comes from the nuclear reactions. Which type of reaction occurs in the sun? Oh, fusion. Fusion, of course. Hydrogen joined together to make a helium. So which one? Helium breaks up. No. Helium joins together. Nope. hydrogen join. It's not breakup, but the joining of hydrogen. This is that D. And two quantities define the Hubble's constant, everyone. So what are they? The speed at which the galaxy is moving away from the Earth, which is called recession velocity or speed. The distance of the galaxy from the Earth, exactly. So simply h0 equals to recession speed or velocity divided by recession velocity divided by distance, yeah? This is the formula. So relationship. So how V is related to D, so simply h0 is always constant, yeah? So V equals to h0 times D. So we can see velocity to be directly related to distance here, yeah? So V is directly related to D. This is correct. So B and D is wrong. A or C. Now, guys, well, you may simply find out this is speed of light, so you may exclude C. But let's say you are confusing a little bit. Guys, units are different. How we can find the unit of h0? So h0 equals to velocity over d. So velocity is meter per second, distance is meter. So meter cancels, second -1 is the answer. So you may catch up or find out with the unit as well here. So correct answer is A. So we are here done. So good luck for your exams.